Alright everybody, here are the notes for lesson 3.4. It's functions, graphs, applications, and models. I split these notes into two sets because I eliminated some problems. So here tells you about turning points and end behavior. So here's our three basic graphs. F of x equals x, f of x equals x cubed, and x to the fifth. These all have odd numbered exponents, so these are all odd degree because the leading exponent is odd. So they're odd degree, odd functions, exhibit symmetry about the origin. Each has domain, negative infinity to infinity, range negative infinity to infinity. It's continuous on its entire domain, negative infinity to infinity. Additionally, these odd functions are continuous on their entire domain, negative infinity to infinity, appearing as they fall to the left and rise to the right. So these three graphs, 2, 4, and 6, are all even numbers, so each graph above has even degree, is an even function, exhibiting symmetry about the y-axis. Each has domain, negative infinity to infinity, but restricted range 0 to infinity, or it would be k to infinity. These even functions are also continuous on their entire domain, negative infinity to infinity. However, they are decreasing from negative infinity to 0, increasing from 0 to infinity, appearing as they both rise to the right and to the left. Okay, so graphs of general polynomial functions. You've already seen this a lot. When a is greater than 1, the graph is stretched vertically, making it narrower. If it's 0, less than a, less than 1, the graph is shrunk or compressed vertically, making it wider. If the negative is in front, it's reflected across the x-axis. So this is shifted k units up. If k is positive, k units down. If k is negative, it's translated h units right. If h is positive, h units left. If h is negative, because remember it's opposite, and this shows a combination of these translations. So look, +1 means that this would go up 1. So you would just go up 1 and it's going to be like a cubic function. This one is still an odd function, so it's going to go left or right 2. So this one's an even function, so it's still a u. So it's going to go left 3, up 5. It's reflected and it would be wider. So left 3, up 5, wider by a half, reflected over x-axis. Unless otherwise restricted, the domain of a polynomial function is the set of real numbers Polynomial functions are smooth continuous curves on the interval negative infinity to infinity. The range of a polynomial function of odd degree is also the set of real numbers. A polynomial function of even degree has the range of k to infinity or negative infinity to k for some real number k. Okay, so end behavior. This is the first one's for the identity function. The second one is for even functions. And this one is for odd functions. Okay, a polynomial function of degree n has at most n minus 1 turning points with at least one turning point between each pair of successive zeros. If a is greater than 0, then as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. We symbolize its end behavior. The left goes down, the right goes up, because these are for odd degrees. If a is less than 0, then as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches positive infinity. So it's reflected. The left side's up and the right side's down. So for even functions, as a is greater than 0, then as the absolute value of x approaches infinity, f of x approaches infinity. We symbolize this as both go up. If a is less than 0, then as x approaches infinity, f of x approaches negative infinity, and we symbolize it as that. So like this. This first one is negative of even degree, so the end behavior would look like that. This one is cubic and it's positive, so left side down, right side up. This is negative and an odd number, so left side up, right side down. This is an even number and positive, so the ends of both graphs would look like that. Okay, that's all for 3.4a.